Hi, today we are going to solve this integral using integration by parts and this formula. First of all, we need to choose our u, and here our u will be ln x. Why we chose this one? Because of when we will write du, it will be d of ln x, which is equal to derivative of logarithm x dx, and it will be dx divided by x, so it will be simpler for us. And now we have dv. dv here is x and dx. So dv is equal to x dx, and therefore our v is equal to integral of x dx, which is equal to x squared divided by 2. And here we can put our constant c, 0. So now we have u, du, and v. And we can use our formula. So it will be ln x u multiplied by v, x squared divided by 2, minus integral of v du. So integral of x squared divided by 2 du, and du is equal to dx divided by x. And here we can see that x squared and x we can subtract from 2, 1, and obtain ln x multiplied by x squared divided by 2 minus integral of 1 divided by 2 we can put in front of our integral, and it will be x dx. So then our last step, ln x multiplied by x squared divided by 2 minus 1 divided by 2. And here we have x squared divided by 2 and plus constant, where constant from real numbers. And well, let's rewrite it in more simpler form. Minus x squared divided by 4 plus c. And here we used, and here actually too, we used formula. It's a quick reminder. X to the power of m, integral of x to the power of m dx, is equal to x to the power of m plus 1 divided by m plus 1 plus c. So that's an answer to our question, to our integral.